I'm Parker Evans. I'm actually in the Translational Plant Sciences graduate program and the Mechanical and Aerospace Engineering department there. My advisors are Vishnu Sundaresan and Katrina Cornish. So as the name of my program suggests, I translate research between different scientific disciplines. In the case of my PhD thesis, what I'm doing is I'm translating electronic control strategies to biological processes. So the fundamental problem here is that our electronic processes communicate and utilize electrons, or our biological processes are primarily ionic in nature. This creates a language barrier between the control strategies we want to use and the systems we want to control. So my thesis uses conducting polymers, depicted by our spaghetti and meatball model here, to address and overcome this language barrier. So in our spaghetti and meatball model, the black spaghetti represents an electron-conducting polymer backbone, while the orange meatballs represent an ion-conducting polymer dopant. So my conducting polymer devices allow me to control the concentration of any anion or cation in volumes ranging from a few microliters to tens of milliliters, as demonstrated by our 10 milliliter beaker here, which you can see starts at a full volume of pH 5, and then when I reduce the polymer, is actually moved to regions of pH 7 and pH 5. Then when I oxidize the polymer, I'm actually able to reverse that gradient into regions of pH 5 and pH 7 again. So now we can translate really complicated messages to very diverse biological systems. So what do you want to say? I'm interested in stronger, more sustainable materials, capturing carbon from the air, and creating functional prosthetics. So the specific aims of my dissertation are to actually establish the system here and then control the synthesis of natural rubber in Katrina Cornish's lab. We work again with the carbon capture team through the Center for Applied Plant Sciences to continue to capture carbon and reuse it. And then, once we've established control over these functional systems, we're going to be exploring control strategies to restore malfunctioning systems. And in conclusion, this represents the ability to translate between electronic and ionic systems, represents a fundamental breakthrough to apply biology towards the grand challenges of engineering. Thank you.